Greetings. False position number 2. False position is a marvelous way of solving a problem, but you also have to know exactly what it is you're up against. And with the Egyptians, they're going to actually have another method of false position that they're going to use. And they're going to say, let's begin with this idea. That ax plus b is equal to 0. Because if it's not equal to 0, I can do some arithmetic. I can get b over on the other side. And with this particular methodology is going to use 2 guesses. So I'm going to allow for guess 1 and guess 2 to take place. So if guess 1 is made, I now have the equation a guess 1 plus b is equal to some false position 1. I'm also given a times g2 plus b is some second false position. It's not hard to make 2 guesses. It's not hard to get 2 false positions. Tickety-boo, we're good to go. Now then, let's get the difference of these 2 equations. ag1 minus ag2, the b's add out, is f1 minus f2. I can also write this as a times the difference of the 2 guesses is the difference of the 2 false positions. Now, with that being the case, we're in pretty good shape. Now, this was the fascinating part. Now, let's take these 2 equations right here and do something to them. I'm going to take the first equation and multiply everything by guess number 2. So I now get ag1g2 plus bg2 equals f1g2. Take guess 1 and multiply it to the new equation. So I get ag1g2 plus bg1 is equal to f2g1. Now I did that so I could perform an elimination. I want to subtract these 2 equations. And now I see that ag1g2's will go away, and I'm left with bg2 minus bg1 is f1g2 minus f2g1. Now this looks like a whole bunch of hogwash, but wait a minute, I'm about to give you the big answer. Let's take this equation and divide it by the equation we had over there. You're probably wondering why in the world anybody would want to do this. Well, let's do it and take a look. And we're going to have f1g2 minus f2g1 divided by f1 minus f2. I can factor the b out over here, and this would simplify to give me the opposite of b over a. So the opposite of b over a is equal to this over here, and you're thinking, okay, so what? Go back to the original equation. Use your algebra skills and solve this equation, and you note that x is equal to the opposite of b over a. But the opposite of b over a is this difference right here. So by making 2 guesses, I don't have to really do anything but just plug a bunch of numbers in to this formula, and I can solve a problem. Let's do an example. Suppose I have 4x plus 10 equals 0. Now, I'm going to make a guess 1 and I'm going to make a guess 2, and we'll see what happens. Guess 1, I'm going to pick 1. So if guess 1, if x is 1, 4, that gives me f1 of 14. Guess 2, I'm simply going to choose 2. f2, therefore, is going to be equal to what? 18. Now, because of this, let's go to this formula, because I know the opposite of b over a is the solution to this equation, and I have a formula for it. F1, 14, times the second guess, which is 2, minus the second false position times the first guess over the difference of the guesses. Now let's watch what's going to happen. 14 times 2, I still think is 28. From that, I'm going to take 18, and I'm going to divide by a negative 4. So this is going to give me 10 over negative 4. Sorry, I got a negative answer. I shouldn't, because the Egyptians would have known what the heck to do with it. But this is still going to give me 5 over 2 negative as the answer to the equation. I claim that answer, when plugged in here, tickety-boo gives you the correct solution. So for the Egyptians, they do have some methods for solving simple problems like linear equations, and they worked them out. And that's what we find in the Rhind Papyrus. You can think of the Rhind Papyrus basically almost as a user's manual on doing arithmetic. And that's probably what it was, and it was probably why it existed. It may have actually been an early form of maybe a textbook or something that a scribe would keep so that they would know how to solve certain problems when faced with them. We hadn't gotten yet into development where people were just running around solving problems using modern notation. I hope this helps.